Hi everyone, and welcome to our video for lesson 1.5, Solving Inequalities. Today we're going to explore how solving an inequality is similar to and different from solving an equation. On your guided notes, we're going to just write down a few facts for you to remember about solving and graphing inequalities. The first thing is when you are trying to solve an inequality, just like with solving an equation, you want to get your variable by itself. Something that's important to remember is that when you are multiplying or dividing by a negative number, the inequality symbol that you have in your problem is going to change directions. Also, something different about solving inequalities is when we have a solution, we're going to graph it on a number line. So if you have an inequality with the less than or greater than symbol, you're going to graph your solution region on your number line using an open circle. Using that open circle indicates that the solution that you have is not part of the solution set. If you have an inequality with the greater than equal to or less than equal to symbol, you're going to be graphing your solution with a closed circle, which indicates that the point that you are graphing is a part of the solution set. Next, we're going to do some examples together. So starting with example number 1 on your guided notes, we are solving for t. The first thing I'm going to want to do in my problem is to take my 2 and distribute it to the parentheses so that I end up with an 8t plus 18 less than or equal to 18. From here, my goal is to get t by itself, so I'm going to be subtracting 18 to the other side of the problem, which will leave me with 8t on the left side and 0 on the right side. Lastly, to get t by itself, I'm going to divide both sides by 8. And when I divide by 8, I get for an answer t is less than or equal to 0. Next, we're going to write our solution in something that's called set builder notation. So starting with curly braces, I'm going to define my variable, which is t, draw a little line after it, and then write the solution that I just found. T is less than or equal to 0. To read this answer, we're saying t, our variable, such that t is less than or equal to 0. The last thing we're going to want to do with this solution is to graph it on our number line. So since we are using the less than equal to symbol, okay, we are going to put a closed circle at 0, indicating that the number 0, that value, is part of our solution set. And because our inequality is less than or equal to, we're going to want to shade all the areas on our number line where t is less than 0, which is going to be everything to the left. So now our solution region indicates that t is less than or equal to 0, and our graph matches that t is less than or equal to 0. The next two problems on your page, number 2 and number 3, are for you to try on your own and to graph independently. Tomorrow in class, we will go over these two solutions to see if you have the right answer. Now would be a good time in the video for you to pause and try number 2 and number 3 by yourself. You can check your answer tomorrow in class. The next part of your guided notes deals with solving compound inequalities. So as you see in problem number 4, compound inequalities are basically like solving two equations at one time. They're called compound because there is more than one, so we have two inequalities. We're going to do this all at one time. Our goal is to get t by itself. The first thing I would like to do to both sides of my equation is I'm going to subtract 6. Whatever I do in the middle of my problem. So since I'm subtracting 6, I have to also do that to either end, because again, I'm solving 2 equations at one time. So on the left side, 9 minus 6 is going to give me 3, less than, I still have 3t in the middle, which is less than 15 minus 6 gives me 9. Next thing I'm going to do is I'm going to divide every part of my inequality by 3 so that t is by itself. On the left side, I get 1 is less than, t remains in the middle, which is less than 3. So for my set builder notation, I'm defining my variable t such that 1 is less than t is less than 3. The next thing that I want to do is to graph my solution on the number line. I have 2 less than symbols, which means at the number 1 and at the number 3, I'm going to put 2 open circles. This means 1 and 3 are not part of my solution region. However, since t happens to be in the middle of 1 and 3, this inequality tells me any value that is between 1 and 3 is our solution region, which means I'm going to be shading in between 1 and 3. So there's my graph shaded in between the values 1 and 3 to represent the solution region that 1 is less than t is less than 3. For problem number 5, you have another compound inequality, which I would like you to now pause the video and try number 5 by yourself. We'll check the answer together tomorrow in class. And the last problem that I have for you today, problem number 6, is an OR inequality. The purpose of an OR inequality means that we're going to get 2 solutions like we did with our compound inequality. However, not all of the values will be included in our solution region this time. So this is just 2 equations that are written separately. So in the first one, I'm going to be subtracting 1 from both sides, leaving me with 3p less than or equal to 6. Divide both sides by 3. So one solution is p is less than or equal to 2. In my second equation, I'm going to add 9 to both sides so that I get 2p is greater than or equal to 16. Divide both sides by 2 to get p is greater than or equal to 8. For my set builder notation, I'm going to start off and define my variable and say p such that p is less than or equal to 2, or p is also going to be greater than or equal to 8. Next up, we're going to graph both of these on our number line. Both solutions are less than equal to, greater than equal to symbols, which means we're going to be using closed circles at the number 2 and at the number 8. In my first inequality, we are saying that p is less than or equal to 2. Since p is less than 2, we're going to be shading to the left. In my second inequality, p is greater than 8. So we are going to be shading all the values to the right of 8, which are greater than 8, in opposite directions. Notice how the middle region of our number line between 2 and 8 is left empty. That region is not a part of our solution, so we have all values over here to the left that are less than 2, including the number 2, and greater than 8, including the number 8.